We've had a solid 3 or 4 minutes to compare answers, and I heard great conversations. Let's talk about which ones we specifically want to talk about right this moment. 17? What does 17 say?
Y equals 1 fourth x times in the front.
It's being a little funky, so we'll start without it for a second. Y equals 1/4 x, x minus 8. Now, there are 3 forms for quadratics. What are they? Correct. So this must be in one of the 3 forms. It's not some new form that I didn't teach you. So is it in standard? Does it even look close to standard? No. How about vertex? It's tempting because vertex does have parentheses, but do you see any kind of square right there? No. So what form does this have to be? Intercept. So there must be a way to rewrite this so it kind of looks like the intercept form we like. Any thoughts on that? I did have a couple people ask me on Remind. Yes, Cassidy.
1 fourth x minus 0 x minus 8.
Very good. So this was probably the #1 question I did get on Remind, and I was able to answer them back and let them know. Why is this giving me such a hard time? Okay. So we can rewrite this. Y equals 1/4 x minus 0, x minus 8. And now I can clearly see that this is intercept form. Once I know that I have intercept form, what am I going to do next? What's the approach for graphing? Not yet. What 2 values? There's 2 variables I can identify. P and Q. What's P? 0. What's Q? Good job. Remember that negatives are built into intercept form. So if I see a minus 8, it's a positive 8. So P equals 0, Q equals 8. How am I going to actually use that information to find the vertex? What do we need to find? The average. How do I find the average of 0 and 8? So again, the more you tell me, the more I'll be able to see. So I'm just going to write a little word right there, tell myself that I'm calculating vertex. We're going to find the average. 0 plus 8 divided by 2 equals 4. Let's reason on why this makes sense. What does 0 and 8 represent again? Yep, and where would that be on the graph? Which points? The x. What's the name of this form again? Intercept form. So 0 and 8 are my x-intercepts. So I have an x-intercept at 0. 1, 2, 3, 4, 5, 6, 7, 8. And where did you find is the x value of the vertex? Right at 4, right? And is that reasonable? If I count 1, 2, 3, 4, does this look like I'm halfway? Yes. So I know x equals 4, but what do I not know? How are you going to find that? Go for it. Once you have the setup, I'm fine if you just use your graphing calculator to straight up get it, okay? So if you want to take a second to take out your graphing calculator, do that and actually try this. So in your calculator, you're going to put 1/4 in parentheses or 0.25, parenthesis 4, parenthesis 4 minus 8. And parentheses side by side automatically mean multiplication, so I don't actually need to put I can just do a closed parenthesis and an open parenthesis, and the calculator will know that in between is multiplication. Are we getting -4? So again, take a second, get the enter graphing calculator. What's my vertex? Put it all together. Good job. Now, with intercept form, it's really nice because now I'm going to plot 4, -4. So 1, 2, 3, 4, 1, 2, 3, 4. I don't actually need you to set up a table. How many points do you now have? 3. That technically is enough to draw the quadratic. If you want to get one more, that's fine. But for intercept form, that's as far as I need you to take it. The other two forms, standard and vertex, I do need the table 2 above, 2 below. What else would we ask to say about this graph? Domain? What's my domain? Come on, cooperate. Domain, all real numbers. I know, I don't know why it's doing this to me this morning. Let's try staying with blue. Maybe it has an. We're devoid of technology right now. It's like freaking out. I don't know why. Say it again? I know, but I want to save it for the video. Ah, okay. Domain is all real numbers. What's range? Okay, guys. We're just going to let this take a break. So range is -4 to infinity. Just to wrap up this piece. What else can you say? That's my attempt at drawing a parenthesis with the mouse. Sorry. What other characteristics can we say? Yes. Where's your axis of symmetry? Axis of symmetry, x equals 4. That would be my invisible dotted line that cuts the graph directly in half. A is 1/4. What can you say because A is 1/4? Opens up and is more wide. Very good. How many intercepts? 2. Nice. All right, I'm going to scroll through. Were there any others from the homework you wanted to see? So 16 is just like 17, but let's see how it is just the same. What kind of form do I have here? Intercept. What's P? What's Q? 1 and -1. How do I find the vertex?
1 - 1.
Yes, and the reason she's saying 1 - 1 is like 1 plus a -1. So just to make a point, we're finding the average. Divide by 2. What does that equal? Which is okay. So I know my x value of the vertex is 0. How are you going to find the y value? What'd you guys get? Do I know 3 points to graph? What 3 points do I have? Here's 1 intercept. Here's another one. So I have my two intercepts. So when they're saying 1, they're saying 1, 0, and negative 1, 0. What else do I know? Yep. Why is this so skinny? That 4 is much bigger than 1, much more narrow. So intercept form is a very straightforward, identify P and Q, take the average to find your X value, plug it in, get your vertex, done. I would like to put up the graph answer keys for the others. Can we do that? Are we ready to check answers for the rest? All right. Missy is still coming around, so as I change the screen, if you need help to wrap this one up, just let her know. So here's the answers for the front. Go to the front. Let me know when I can scroll. Good? Zeros and our x-intercepts. Yes. So solutions to quadratic equations are called zeros and roots. So, for example, in this graph, this has 1, why 3 zeros? We'll talk zeros tomorrow. No. So let's go by roots. So right now, for all intents and purposes, roots are x-intercepts. Zeros we'll talk about tomorrow. That's a different element we'll talk more about. So as of today, right now, roots are x-intercepts. Very good. Ready to check graphs? Yes? Who's ready to check graphs? Okay. So let's talk through 12 real quick. What form do I have for 12? We did 12 together. Who said talk through 12? You're making me second guess myself. I can't remember from Friday. 13. Did you mean 13 to talk about? No? We did 12, but somebody had said to do one out, so I was just trying to figure out which one that was. I had some good questions on Remind for 13. What form is 13 in? Standard. What's the B term? 0. That was the key for that one. 14. This is a check, so for us to check, it has to be done. If you need to catch up on the assignment, and then we'll check ourselves. Ready for 14? There's 14. Which one? You got it? Yeah. Okay. 15. We're going to be practicing some more graphing today. So if anybody was in need of more practice, we will practice today. And then 16 and 17 we talked about. Okay. I'll leave that up for just one more second. We're going to practice graphing a couple by hand right now before we move on. Do we need more graphing practice, or are we ready? We're ready. Who wants more graphing practice? All right. We'll do at least one more before we move on.
What'd you say?
How fast?
Yeah. What did you say?
So go ahead and put today's date at the top of this. Graphing practice. There is a shiny side to the graph paper and a not so shiny side. I recommend you use the non-shiny side. Okay, so directions. Do we have extra graph paper, folks? Did I pass an extra sheet down? Okay. Graph. Y equals negative 2x squared minus 8x. Horrible 8. Minus 8x plus 6. What form is this in? Standard. So what values are we going to identify first? Like how Smartboard just switched between blue and green there for you. What are we going to do first for standard form? So anybody who is struggling with graphing, intensely paying attention right now. Find the vertex. How are we going to calculate the vertex? Yes. So negative b divided by 2a is going to look like what here? So this is the formula we're using. And I'm asking, what's that going to look like for this? Yes, because I have a negative built in. So this is going to be a negative 8 divided by 2 times negative 2. That negative, as was just commented, becomes positive 8 divided by negative 4 equals negative 2. Now that I have the x values of the vertex, what are we going to do? Yes, f of negative 2. Again, at this point, I am confident in our evaluating skills. So once you get the setup, you can use your graphing calculators to get that value for us. Be careful that you use parentheses appropriately. Let me know what you get for the y value. If anybody needs help putting that into the graphing calculators, let us know. $14? Yes for 14? Yes. So putting those two pieces of information together, what's the vertex? Good. We found the vertex. What's next? Table. Where are we going to make sure we put the vertex? Right in the middle. And now we're going to get 2 points. So if I count backwards from negative 2, forwards, which 2 points would you like to evaluate? I would vote these two because 0 is involved. In fact, do I already know when x is 0, what's y? Something special about standard form, about that c value, 6. I'm going to attempt to change colors and hopefully the Smartboard doesn't yell at me. With standard form, I automatically am given the y-intercept, which is how I knew that this was 6. Now, if you didn't realize that or you didn't remember that, if you actually calculate f of 0, you will get 6. So it's not a huge deal. Yes, it does. And visualize this, right? If I were to substitute 0 in for x, where here I see x squared, what does this whole term become? 0. And then 8 times 0 is 0, just leaving 6. So, like I said, if you forget that c is the y-intercept, if you were to evaluate 0, you would get 6. What's left for us to calculate? F of -1. If you hit second entry, it should pull up this line of work, and then you can just scroll over and change the 2's to 1s. Yes. Second enter. If anybody needs help seeing how to do that, let us know. You see it? 12? Where does 12 go in the table? Yep. Now that I have my 5 points, what are we going to do? Go for it. So sketch yourself a graph. Decide what you're going to count by. How's the graph coming out? Because I don't have graph paper on the smartboard. Should be skinnier. Who's done with their graph? Let's take out our graphing calculator. So let's go into our graphing feature. And let's type in -2x squared. You have an x squared button here off to the side. -2x squared minus 8x plus 6. Hit enter. It's a good practice after you hit enter, zoom 6. So the zoom button is here. So after you have it entered, zoom 6. What button am I calling if I say 6? Standard. So it makes it a standard 10 by 10. Not big enough. So if we go back to zoom, what maybe do we want to try? Zoom out. Let's try zoom out. And then hit enter. I hit enter. Did you hit enter? You get a blinking dot on 0, 0 because it's asking, do you want me to zoom out from here? And you say yes. Who didn't do that?
Oh, you said extra. Oh, yeah.
Hit enter. Once you hit out, hit enter again after you see the graph, and you'll see it zoom out. We'll play with windows in a little bit. Missy will come around to help you with windows as well. What I would like you to do right now is hit second, and then above the graph, what do you see as a blue word right there? Table. So really you're hitting second and then the graph, but really what are you calling on? The table. Yep. Second graph is really getting you to your table. Do you see the values that you just got? Check your table on your graph paper. And then check the table in the calculator. Notice something awesome? Second graph is really second table. So second. There you go. Now you can scroll up or down. All right, let's practice one more. One more graph. Y equals y equals -1/2 times x plus 3 all squared plus 4. What form is this in? Vertex. How do you know? Yes. I clearly see I have x plus or minus a value, but really that's not as important because technically it could be x plus what if I didn't see a number? This is a fun question. Is this in, what form is that? It's vertex. What could it also be? Oh, how cool is that? Check it out, right? If I write it in vertex form, which I would recommend because it's faster, that would be vertex form, right? What's your vertex right away? 0, 4. Sorry, thanks. 0, 4. In standard form, this would make an awesome quiz question. -1/2 x squared. What's the b term? B. And if I calculated negative b over 2a, what would be in the numerator? Divided by any number is, so it still works out. I'm going to keep that one in mind. That's a good one. So yes, this is vertex form. What is the vertex of the given function? I'll stop going on a tangent, sorry. What's the vertex of this given function? Why did she say -3, 4? Built-in negative, very good. So that's the nice thing about vertex form is there is no work involved. What are we going to do next? Yes. Anybody want to try doing it in the graphing calculator instead? Yes, let's do it. All right. Now that we have this awesome tool at our disposal, let's use it. So go back to y equals, clear out y1. Clear, clear, clear. Now be very careful. Use parentheses for -1/2. So open parenthesis, -1/2. Close it. Keep it inside. So the question was, can the negative go out front? I would recommend you just keep it inside. So in parentheses, -1/2, and then an open parentheses, x plus 3, close it, squared plus 4. How do I get a 10 by 10 box as I graph right now? What am I going to hit? Zoom, nope, zoom 6. Always have zoom 6 as your go-to. If your graph's not working out, let us know. Who got the graph? Awesome. So we're going to keep this on the back burner. We know that we should get graphs that look nice. Now we're going to try to get graphs that look nice on our own. Oh, all right. Let's set up a table. No, but we will use the table to verify our answers. So where's the vertex going to go? Now let's reason on this for a second. What am I ultimately going to have to multiply by out front? 1/2. So it would be really nice if the numbers inside parentheses came out to be what kind of number? Even. Even. So can we reason on what kind of number I have to plug in? Well, I plugged in -3. If I go 1 away, what's that? But if I mentally check, what's -2 plus 3? -2 plus 3? -1. Is 1 even? No. So maybe not -3, but maybe not -2, but what could I try next? So let's try -1. We're trying to be smart with the values we plug in. So there's nothing wrong with plugging in. If we did -2, but it would come out to something that's not so easy to grasp. Let's see what you guys get when you evaluate -1.
Good morning, East River High School. Today is October 24th. Please stand for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
How far away is -1 from -3? 2. So I would go 2 away and I would get...
Have a day, Expo.
Yes. And if we kept that up, what's 2 away again from -1? Good. So the purpose of this was not to teach you vertex form. We've done vertex form. But how to be strategic in choosing x values when you have a fraction out front. What I'm going to be doing for tonight is posting a video on Real World. Your job is to watch it for the first 2. The next 3 days, I will actually be in a training. So I will be staying after and making 3 days worth of class note videos, 2 days of which go with this, and then 1 will be starting something new. So when I emphasize to you the importance of using Remind, I genuinely mean please, please, please get in touch with me. Yes, in my notes, I'll be doing the first 2. Homework will be the next 5. So watch the videos so I can do the first 2 with you. It's going to be a quick video, like 10 minutes, and then you're going to do the next 5 for homework.
So we're only going up to 7?
Yes. If you would like to keep going, you can. It seems like a thick packet, but it's only because it's very spread out. So this is a real-world application of quadratics. I promise you it is not bad. Well, nothing we do is bad. But it is very direct once we realize there's a very common approach to finding the vertex and seeing what it means. You're welcome. I would like to take a minute right now. If you are not signed up for Remind, I want you to come back there and I will sign you up right now. Oh. Who needed an extra copy of the homework? I had them here. Oh. Here we go. So Remind people, come see me in the back. We'll take care of that right now. Yes. Those early announcements are killing me. I'm not sure how much time we have, but Can anybody finish finding f of 1 and f of -7? I have a couple who have been amazing and have continued. And then can you graph it? We got to remember that announcements are early sometimes, so we still work till the bell. Plenty of time. So let's finish that graph, please.
Not this, but every time I
Marcel, let's finish that graph.
to plug something in, when we do it like actual, like this, for example, it would always say error. I don't know.
You got to type something in first.
No, I'm saying, but when we're doing like this,
Okay.
like to find out the numbers and then find out two.
Even if you're finishing it just on the graphing calculator, I want to see you working on that graph. So get out your graphing calculators and be working. Oh, bummer. Working until the bell from now on, folks. Let's try.